Maybe a round of applause for KATARINA.
Yeah. Hey. Are you guys ready to learn everything you never wanted to know about testing user interface or MCU devices? Well, as my coworker introduced me, I'm Kati, and I'm going to tell you how you can automate testing of your Qt Ultralite applications on microcontrollers devices such as this one here, and how you can do that with Squish, our universal tool for automated testing of user interfaces. Here's some brief agenda for today. We are going to have a quick look what the microcontrollers are and what Qt Ultralite is. Since we are on Qt World Summit, I assume everybody in the room knows what Qt is, so I'm not going to explain that. Then we will have a look. Why is it so challenging to implement user interface testing on microcontrollers? And also how we overcame some of these challenges with Squish, our tool for user interface automation. We will look at some advantages the using of Squish has. And then we have a quick look at its architecture. If all goes well, there will be even a demo in which we connect to the device, record some simple test case, verify, replay, and hope everything will pass. And finally, there will be some future insights into what we plan for testing user interfaces on MCUs next. All right, so microcontrollers are the small computers on integrated circuits, such as this one here. My microcontroller unit is on the debug probe. That's the yellow box I'm holding. And it helps me to communicate with the device and to upload my application that I want to test on it. For the purpose of this talk, there could be another separate talk about microcontrollers only, but for the purpose of this talk, we will limit ourselves to listing some resource constraints that exist on this platform. So, in comparison with testing regular user interface on desktops, on embedded devices, we have much less CPU power on the microcontrollers. The applications we put on microcontrollers need to have much smaller memory footprint, and perhaps the most significant limitation is that we have much less storage space. So Qt Ultralite is a subset of Qt, which was developed with the emphasis to optimized to use in this very resource-limited environment on the microcontrollers. And if you know Qt, you know it contains all these bells and whistles. There's the QML declarative language. There are some APIs, Qt C++ APIs, non-graphical APIs, such as network communication, some add-ons for multimedia, standalone JavaScript, etc. But since we have so little space on the microcontrollers, the engineers of Qt company took some of these APIs that were not essential and removed it. And this is in very simplified form how Qt Ultralite came to be. So why is it so difficult to test anything at all on microcontrollers? As I already stated, we have these limitations on CPU power, on the memory footprint, and on the storage space. So the way we usually test Qt applications with Squish, but other tools do this as well, is that we have either a larger piece of code that does essentially two things: simulates the user input, also, in other words, pretends it was the user who clicked the mouse, who typed something, who tapped on the screen, but actually it's automated script kind of doing these things. And then we need to from the application we're testing, we need to collect some data, which we can then verify. So it's either done with a larger piece of code, which we call wrapper, Qt wrapper in this time, or a smaller piece of code that we inject into the application, which we called Squish built-in hook. But for that, we need network. This particular device doesn't even have an Ethernet connector. Some do, but even with the Ethernet connector, we would need the full network stack to actually get some data out of the device through Ethernet. And if you remember the previous slide, network API is one of those non-essential ones that are not part of Qt Ultralite. So, given all of this, we don't have any spatial awareness. So what that means is if I tap the screen here, then the user interface tester has no idea what happened here, because doesn't know that anybody tapped on the screen and where did it happen. So we don't have any spatial awareness, like what are the X and Y coordinates of the user event that just happened. And also we don't have object awareness, because for all of that, we would need all these, like either wrapper or the built-in hook that like can get us all the data about the object tree and about the object properties from the application. But then comes the tiny piece of code, which is called device link. And it does essentially two things. And it's so tiny that it actually fits the device alongside the application we are testing and Qt Ultralite runtime. So this tiny piece of code does two things, and it does it very well. It emulates the user input. So my test scripts then can pretend that user actually tapped on the screen. It does it in a way that it synthesizes these user events and injects them into the application, and it gives us access to the image data, which we can, like all the pixels on the screen, which we can then use to do image-based testing. And since image-based testing is, and like over the image-based testing, we can add to the image-based testing, we can add OCR, optical character recognition. So we can even like recognize some text. So with all of this, what we can do, we can emulate those user events and inject them from the outside to our application. We can test for the presence of specific image in the application. We can run OCR over the screen and see if the specific text is present. And we can do visual and screenshot verifications. Don't have object awareness yet, but about that we will see later. Okay, so why would you want to choose Squish for testing user interface on MCUs? The very simplest answer to that is that it's the alternative to the manual testing. So as this classic quip goes, if you really want to annoy and frustrate people at your workplace, have them do tons of manual testing. Nobody wants to do that. And for Qt Ultralite, it is actually the only alternative to manual testing on the market. We have some choice of supported hardware. We have those so-called Tier 1 target boards. Those are the MCUs that received the highest level of support from Qt company, from Qt for MCUs team. And out of these four boards, for vendors with the highest level of support, we support these two, STM and NXPs. And if you ever use Squish for testing anything at all, Qt, but also Windows, Web, Java, whatever, you will find all these concepts that we use for testing MCUs very familiar. So you will recognize the image and OCR-based testing and those screenshot and visual verification points. And with Squish, you have the full power of Squish IDE at your fingertips. So there's a wide choice of the scripting languages. We have 5. So you can write test scripts in 5 different scripting languages. The most popular one of these are Python and Perl. With the IDE, you have a powerful code completion, syntax highlighting, text debugging, and if this all is not powerful enough, what also is there, you can write test suites for the MCU devices and integrate them into your existing test suite test cases, share the resources among the test suite and test cases, and what's like great selling point, you can plug all those automated tests into your continuous integration, make them part of your pipeline, and test user interface, I don't know, with every commit or daily. It's kind of clear that it is not within the human powers to do all of this manually. So with the help of Squish, you can automate testing of the user interfaces on MCUs. All right, so this is some architecture. How does Squish for MCUs look like? I'm holding the MCU board. There is the application I'm testing, the device link, that's this tiny piece of code that actually helps me to test. There's Qt Ultralite runtime, and of course the application that is made testable. This yellow thingy my board is on, it actually happens to be yellow on my slide as well. It's the debug probe, which is some additional board the device is on, and it helps me, for example, to upload the testable application to my device. What we also need is the serial connection to my PC. That will help me retrieve the image data from the Qt Ultralite application and do image-based testing with them. And on the PC, on my laptop, I have Squish. I have the IDE, the command line interface, and I have also vendor tools, which come from the third-party vendors that actually sell these MCU devices. And I use their tools to communicate with the device and to flash it. All right. So before I try to show a demo, which can be a little bit challenging, let's do some pre-flight check and see what do we need to even get started testing Qt Ultralite applications on MCU devices. It will be more or less what we saw on the previous slide. So on my PC, I need the enterprise license to be able to use Squish for MCUs. It's downloadable as a binary package for Windows and Linux from our customer download area. I will need the vendor tools that I download from the vendor of the microcontroller, but Squish installer can help you with it. Has some like helpful user interface to actually locate these tools and to install them. Optional, but very useful, is the OCR engine. So I can do not only image-based, but also OCR-based testing. So I don't rely only on text as an image, but I can actually like recognize it as a text. So this is recommended. With Squish license, you have a free access to Tesseract OCR, which you can also download as a binary packages for all platforms. But we support some 2 additional OCR engines as well. And on the board itself, as I said, this is a serial connection to my PC. I need the application that needs some extra tweaking, some extra rebuild to be actually made testable. It needs to have this device link enabled. If you remember, that's this tiny piece of code that injects the user input into the application and helps us retrieve the data. And then I will use the vendor tools to flash the application onto the device. All right. let's do some demo. Okay, so in the Squish IDE, let you see, is the font size okay? Yeah, all right. I will open a new test with my mouse. And I put this in my mouse. And I will bonk this red button, which will, that's a recording mode. So Squish will now record whatever happens in the application. And we see what happens. Connecting to the device. And as I said, the events that happen on the screen, since we don't have this object awareness and spatial awareness, Squish would not detect them. So if I want to interact with my device now, I have to insert this tap event from outside, which is what I'm going to do. So I will insert a click on the image. Let's say, so what I'm going to do is that so this is a simple application that's some sort of thermoregulation. And I'm going to, that regulates the temperature in the house. So what I'm going to do is that I'm going to tap on this green button and switch the thermal off for this particular room. So this is what's going to happen. But have to. So the way I do it is that I search the screen for the particular image, which looks like this. That's the green button that you perhaps saw on my MCU device, and I'm gonna insert the click on that device, on that image. And afterwards, what I would like to do is that, yes, and once I have done this, I would like to verify that the status report in my application actually was switched, and it says that the thermo is off. So what I'm going to do is that I'm going to verify that a specific OCR text which says off is present. So I'm going to scan the whole screen with OCR now. And I'm going to search for specific text which lives here. And I'm going to, so my test is going to check that this very text is present. And let's say I'm happy with the recording right now. So I'm going to finish the recording. And we see this like nice simple script in Python scripting language. I will quickly go step by step through it. The first line, it's the API call that helps the user interface tester to actually connect to the device. The second line is the mouse click on a specific image, which lives, I think I have it here. No. This one. So we see how we clicked on the image of the green button, and after we did, we test that the image with the off button is present. And as a last step, we check that the OCR text, which says off, thermo is off, is present. So what I'm going to do now is I'm going to replay the test case. And see if it passes. Oh. I think I replayed the wrong test case. Here. Right. It takes a while. because they need to collect the image data from the screen. And the first image was found, and the second image was found, and the OCR text was also there. Wow. Anyway, so this was the live demo of Squish for MCUs on my STM device, like very simple thing to showcase here. There's like but they are like much more complex application, and image-based testing can actually be made quite powerful. So that's what you can do with what you can do at the moment on MCU devices. And I'm going to come back to my slides and share some future insights with you. So what we plan to do with Squish for MCUs next. You remember this diagram? I showed it earlier. So the next step is to add the object awareness to Squish for MCUs, which will help us not only access the image-based data, pixels on the screen and the text processed by OCR, but the full tree of objects my application consists of, and the full depth of their properties. So then we can do much more sophisticated verifications than those that I just showed you now. We plan to also extend the support of the boards on which you can currently test the MCU boards where you can test applications written Qt Ultralite. So at the moment we support STM and NXP devices, which are like 2 among those 4 boards that are in Tier 1 category. And in the future, we plan to extend the support to more boards that are currently in Tier 2 and Tier 3 categories. And probably the next one is going to be this one, Espressif ESP32 device. And in the long run, we plan to automate testing of more GUI toolkits. So you would be able to test not only applications written with Qt Ultralite, but one of the other toolkits where you can write your GUI applications for MSC devices is LVGL. It is also something we are looking into supporting, where you can write automated tests and automate testing of LVGL GUI applications on the microcontrollers. So let's summarize this a bit. As a conclusion, Qt Ultralite is a subset of Qt, which is optimized for MCU devices. You can use Squish to test user interface on MCU devices with the help of automated image and OCR-based testing. You can you can use the full power of Squish IDE to implement those user interface tests, and you can seamlessly integrate those tests into your pipeline, into your test infrastructure, and into the continuous integration. All right, so that would be it. Samir.